No, sir.
Yes. So can we discuss? We will first discuss the solution. Okay. Then we will further solve couple of questions. Then we will move for the new topic. The
Okay,
remaining
sir.
quantities. So we have this question. A constant force. It's already said that the force is constant. A constant force of 8 would act on a mass of 5 kg object, right?
Yes, sir.
So it says a constant force. How will you proceed to do this problem?
For the first question, find the magnitude of the applied force. We first write m is equal to 5 kg. Time t is equal to 2 seconds. U is the initial velocity is 3 meter per second and the final velocity is 7 meter per second. So then to find the magnitude of the applied force, we know that force is equal to m into a, but we don't have acceleration. So to find acceleration, the formula is v minus u by t. So we will put it as 5 kg into 7 meter per second minus 3 meter per second by 2 seconds.
So as you have already forwarded me the solution, I can see you have written I'm having some difficulty in this. I don't know why. Give me some second. Okay.
Okay, sir.
So you written the first line. I will write it again. Okay. And I will point you out. You just written F is equal to M time P minus U, right? You check your solution.
No, it's by t. That time I didn't put it that time.
Okay, so this is T. So this was one point I was about to tell you. After that, your solution is mass is given 5 kg. Mass is given
Yes.
5 kg. And uh, that is the object velocity from 3 to 7. Okay. So what is final velocity over here?
7 meters per second.
7 minus 3. So there is no point to write the dimensionality of quantity over here. Okay. As you have
Okay.
written 5 kg into 7 into this minus this like that. So there is no point. We will finally substitute this dimensionality and solve it. We all know that force is Newton. So it will unnecessarily make the thing more complex. Okay.
Okay, sir.
Did you get my point? If you wish, you may continue. But my suggestion is that it will make your calculation bit tough. And
Okay, sir.
from 3 to 7 meter per second, it takes how many time? 2
2
seconds,
seconds.
right? Okay, so this is 2 seconds. So we are with 5 into 4 divided by 2, right? So how much
Yes.
we get? 10, right?
Newton. Yes.
10 Newton. 1 Newton is how much? You have already shown over here. So 1 Newton is this is mass. So mass is what? Kilogram.
Mass kilogram
And this
into
is
meter per.
velocity. Velocity is meter per second, right?
Yes.
And divided by time. So it is again second, right? So what it
Yes.
comes? Kilogram meter
Newton.
per second square. Okay.
Okay.
So what is the next part of the question? Is clear to
It,
you?
yes, sir.
And what is the next part of the question?
It's saying that the duration time has changed to 5 seconds. So they're asking to find the final velocity. So we learned this in the last lesson that final velocity is equal to the initial velocity plus acceleration into time.
Okay. So you are saying that final velocity v is equal to u initial velocity plus a time t, right?
Yes.
Same thing. You have written the same. Okay. So here, as you said that we find that acceleration is missing. So we will be calculating acceleration, right?
Yes, sir.
Okay. Time we have already. So how you calculated the acceleration?
Because the last text time acceleration, I took it from the previous step.
Yes. This is the acceleration. V minus v over. Like this is the acceleration, right?
Yes. So I took that same number
Of
and
course.
kept it with acceleration.
Acceleration is v minus u by t, and then this t is multiplied, right? You did the same. You took the acceleration. Okay. That's 4 by 2. That's the 4 by 2, right? This part.
Yeah.
Okay. So here also, 7 minus 3 is how much? 4.
So,
This t and t is cancelled. So, t is 22 plus 8. It's what is this? So you
no,
substitute.
it won't be cancelled the time because it's by 5 seconds. We're multiplying it with 5 seconds.
Okay. Time is changed, right?
Yeah.
So this quantity is your acceleration or not, right?
Yeah.
So here it was 2 seconds, right? This was the initial
Yeah.
situation.
Yeah.
So now the situation is changed. Acceleration we are 4 by 2 is that is half. 4 by 2 is equal to 2, right?
Yeah.
Are you confused?
Sir, for this acceleration for the second part, we have to change the 2 seconds to 5 seconds.
Find the magnitude of light force if the force was now if the force was applied for a duration of 5 seconds, what would be the final velocity, right? Yeah, of course.
So it will be 7 minus 3 by 5.
Right.
But how, sir?
How? The question is saying that, see the first part, a constant force acts on an object of 5 kg for a duration of 2 meters. It increases the object's velocity from this to this, right?
Yeah.
If the magnitude of applied force, find the magnitude of, now if the force was applied for a duration of 5 seconds, what would be the final velocity? Question is clear to you or not?
Yeah, it is.
Any confusion anywhere?
No, sir.
Can I jump into it? Make your life
Yes, sir.
simpler? See,
Yes, sir.
the question is connected with this force, right?
Yeah.
Once we calculated the force 10 Newton, now we have to write it, write the force that F is what? F is equal to mass time acceleration, right?
Yeah.
Okay, so we now calculated the force, we know the mass. So we can write the acceleration like we can write the acceleration in this fashion as it is given. F over m, right? F over m into t, right? Got the point?
Yes, sir.
Now do it. Now it's okay.
Yes, sir.
Now you check the procedure and get the answer.
Sir, it's 13 meter per second.
Of course, right?
Sir, that's what I thought before also.
Before also. Yeah, of course, you use the acceleration like that. So force is how much? 10 Newton and mass is 5 kg. 10 over 2, how much? 5, right?
That will be 2. So 2 into 5, 10, 30 plus 10, 30. 3 plus 10, 13.
So that's the way. You may do otherwise as well. Okay?
Mm.
Any confusion?
No, sir.
Okay. So can we move further?
Yes, sir.
So now I have, this is the plan for the day. We will do some numericals. Okay. You see the application of second laws of motion, third law and its application, and then we will further move for conservation of momentum. So before that, we have this question. A motor car is moving with a velocity of 100 kilometer per hour, right? So how we will
Yes, sir.
proceed? 108 kilometer per hour is what? Is the initial velocity?
Yeah, it's initial.
So 108 kilometers per hour. So how we will change it into meter per second? Will you do it for me?
Uh, So 36 meter per second.
Comes out 36 meter per second. No, I
Yeah.
don't. I don't think. 108, right? 108.
108. So then will become 10,800 meters
108
by 300 seconds.
in 1 kilometer is 1,000 meter, right? In 1 hour is
Sorry, sir, I took two zeros. So it will be uh, it'll be 360 kilometers.
so. See, whatever you are saying, I'm trusting on you. Okay, this will be 5 if we do half. This will be 3. So this will be 108 into 5 by 6, 3 is 18. And now this kilometer is changed into meter, and this is changed
Yeah.
into second. So meter per second, right? Now solve it. Read the table of 18. Read the table of 18.
It will be 6 into 5.
6 into 5. How much it is now?
So then sir, in school we learn like to turn the kilometer into meters. So we turn the number into like adding the zeros at the end and dividing it by 300 seconds.
How? See, in 1 hour, how many minutes we have in 1 hour?
60 minutes.
Okay, 60 minutes, right? In
Yeah.
1 minute, how many seconds we have?
60 seconds.
Okay, so this is minute, so change it, substitute this quantity to here. We are changing in second, okay? We are not changing in minute. So it is meter per second, right? So in
Yeah.
1 hour, there is 3600 seconds, right?
Yeah.
Got the point?
Yes, sir.
Any doubt?
No, I got it, sir.
Any confusion or contradiction with this rule?
No, that's how we used to learn. That's why I got confused.
No. So who is correct?
You, sir.
See, sometime I might be wrong. Okay, so you have to correct. Okay, sometime you might have learned the wrong way. Maybe school teacher intention was not that, or they were not doing in that way. You are understanding it. Got the point?
Yes, sir.
So now make a link between me and a school teacher. What was the difference between the right now we are learning and what that moment he or she told you?
Okay.
Can you connect? What was the reason why you connected that in that way? So it becomes 36. That might help us. Okay, that's why I'm asking.
I think I did it wrong, sir.
Okay, no problem. So it's clear.
Yes, sir.
So read the next part of it.
And it takes 4 seconds to stop after the brakes are applied.
So how we will write this statement in the mathematical form?
It will.
We already written the U. Okay. So
So
yeah.
So to be.
So it says that T is 4 seconds, right?
So final velocity is 0
Oh,
meter per second.
0. Final velocity 0 meter per second, right? Now read
Yes.
the next part.
Calculate the force exerted by the brakes of the on the motor car if its mass along with the passengers is 1000 kg.
Okay. So mass is given, right? Mass of object is given.
Yes.
So we may write mass, capital M. This is 1000 kilogram, right?
Yes, sir.
And the desired is this velocity, right? Desired thing is this velocity. How will you do it?
Mass into acceleration, which is equal to mass into v minus u by time.
That's good. Do it.
Sir,
Yeah.
will it be 0 minus 30 or 30 minus 0?
What we write? V minus u by v. This is acceleration, right?
Yes, so we'll keep it as 0. We have to keep it as 0 minus.
Close your eyes, okay, and substitute the value of the desired quantity. Got my point?
Yes, sir.
I'll explain this thing a little bit further. Okay, see, when we were studying, this was the timeline. Okay, this was T1 and this was T2, right?
Yes.
Corresponding to this was V1 and this was V2. Okay, so if we have to write this, then we will be writing V2 minus V1 and T2 minus T1. Okay, so suppose this is just a minute, hold on. This V2 is V, V2 is V, right? This is 0, and this is V1 is U. So it's 30, right?
Yes.
Okay. So this T1, say T1 is 0 and T2 is 4 seconds, right? The confusion?
Yes.
Okay.
No, sir.
Okay, right? So how we will be defining? See, V minus U, then 0 minus 4. Then instead of T, we will be writing 4 seconds minus 0. Final minus initial velocity. Similarly, final time minus initial time. Got my point?
Sir, both are 0.
Which which quantity you are talking? So to remove the doubt, I will write it again. This is the final velocity, this is initial velocity, right? Corresponding, we have to
Yes.
write the time final minus time initial, right?
Yes.
Order should be in the time and velocity order should be in some sequence. Got my point?
Yeah.
So this final
Mm.
velocity is 0. So just substitute this 0. You don't have to think much. We have given
Okay.
data that this V is nothing but 0. Okay.
Okay.
And this is what 30.
Okay, sir. Thank you.
Most welcome. Are you having any difficulty?
No, sir.
Got the
Sir,
yeah.
is the answer 7,500?
I don't remember.
What, sir?
I don't remember the answer actually. Do you
Uh,
expect that I should remember the answer? Will you show me the procedure?
okay, sir. Just-
Okay, right. I got that. I got that. So for my own satisfaction, I'm writing it again over here. Okay.
Yes, sir.
So and you may correct me if I'm wrong, or correct yourself if you are wrong. Okay. What is
Okay.
force? Force is mass time acceleration. So mass is already given this much 1,000 kg, right?
Hmm.
Then V is 0, U is 30, right? Writing front is
Yeah.
and divided by how much time? It is
One.
divided by time. So final minus initial time is 4 seconds, right?
Yes, sir.
So this will be gone. Let me create some space. I'm erasing this part. Okay. Can I do?
Okay, sir. Yes, sir.
So will you tell me how to process further? What
Uh,
is
we,
the
well, we can put it as 1,000 into minus 30 by 4.
1,000? Can I take minus this side?
Okay, sir.
There's no harm, na?
No, yeah.
Okay, so what next?
Then you can cut 4 with 1,000. It will become minus 250.
Right?
Yes.
Then this is
And then minus 250 into 30 is equal to minus 7,500.
it goes minus 7,020, right?
Yes, sir.
So this is our force, right?
Yes, sir.
So have you ever seen the negative before the force?
No.
This is first time.
Yes, sir.
What does it mean?
I
It's the negative
um,
energy.
yes.
Oh, sorry, negative force, not energy. So can you tell me what does it mean?
What, sir? I couldn't hear you. What did you say?
This is negative force, right?
Yeah.
So what does it mean?
It's less.
It's less and more is when we talk about less and more, there must be some frame of reference. Means that you are smaller than your, what can I say, less. So you have less money than your mama have, right?
Yeah.
In that reference. But you say here it is less, in which reference you are talking. So it's something different, right?
Yeah.
So if force is positive and force
And
is negative,
it's
if force is negative, that means you are working on something. If you are pulling a ball or something, some food or some uh, spot or something, if you are applying force, that is moving away. But if it's negative, means that force is now opposing that motion. When you applied the brake, car was speeding, but as soon as you applied the brake, car start, the car start, the speed starts decreasing. Okay,
okay, sir.
so once the speed is car's speed decreases, finally it stops. So it means that this force is acting against the motion of car, right?
Yes, sir.
Okay. So if you will calculate the acceleration over here, the acceleration we calculated is v minus u over t, matlab means that 30 over 4. This is negative, right?
Yes, sir.
We say it t acceleration. T A double C L E R A T I O. Have you heard about it?
No,
Acceleration
sir.
you heard, na?
Acceleration, her de-acceleration.
So if something is accelerating, its opposite is also possible, right?
Yes, sir.
Brake is applied, the acceleration is now decreasing. So you may say that acceleration is decreasing. Acceleration, de-acceleration, right?
Yes, sir.
Any doubt?
No, sir.
Did you learn anything from this problem?
That if the force is negative, it's a, or if it's negative, it's a negative force. So the acceleration, if it's negative, it's called de-acceleration.
Okay. So you got from your own experience from car when you are moving, someone applies brake. So what happens?
It's at rest.
The speed decreases, right?
Yeah.
Unit time decreases. The same situation is over here. Okay. So
Okay.
have you learned the step of this calculation?
Yes, sir.
100%?
Yes, sir.
No doubt.
No, sir.
So to take the point where you were having some confusion when you were calculating the kilometer per hour to meter per second. Keep that in mind for the next time. Okay.
Okay, sir.
So this is another problem. We have, so you keep this problem. I think we lost most of the time in solving this problem, right? That problem. Okay. It took almost 40 minutes.
Okay. Um,
So can you explain this question? What is it?
The velocity time graph of a ball of mass 20 grams moving along a straight line on a long table is given in figure 8.9. How much force does a table exert on the ball to bring it in rest?
Yes, so see, the situation is same. As the time passes, velocity of a ball decreasing. Okay, from 20 centimeter per second to 0 centimeter per second, right?
Yes, sir.
In how much second? 10 seconds, right?
Yes.
So we have T already 10 seconds. Initial velocity is 20 centimeter per second, and the final velocity is 0. Okay, so force is being asked, right?
Yes, sir.
So you do it in your homework, right?
Okay.
So keep the question number and do it your the classroom. Sorry, in homework assignments, because we almost took 40 hours, 40 minutes to solve that numerical. You keep and show me next time. Okay. So
Okay, sir.
the next thing is application of Newton's second law. So what was the Newton's second law? We discussed that law in the form of change in momentum, right?
Yes, sir.
So what is momentum? Do you remember?
Momentum is the when the object is in motion.
Momentum was if if any object of mass m is in motion with velocity v, right? Product of mass into velocity was momentum, right?
Yes, sir.
You remember?
Yeah. And yes, sir.
See, have you seen the cricket match?
Yes.
The act of catch.
Yes, sir.
So, Do you remember what he's doing in this figure?
He's catching the ball and its inertia is happening.
Okay, so it's inertia is happening. Actually, if he will keep his hand like that only, the first figure is it's like this figure. The ball will hit his hand, or that may injure his hand, or it may just bounce back. Have you seen this situation? How it
Yes,
can
sir.
because the, he is not giving the right momentum. If he is pushing his hand back, so means that he is giving it the right way of catching. If he is somehow trying to save himself because ball has some velocity. If you will drag it back, the velocity will be continued for some time and then it will stop automatically. Right? Some force
Yeah.
from our hand, some from there, so it will be get cancelled. So this was one of the utilization of second law. It's okay.
Yes, sir.
So another thing is that in high jump, this is the sands. Okay. So when an athlete jumps, the sand is being here either to sand or something to prevent the injury of athletes. Okay.
Yes, sir.
Same situation. Now the another situation is seat belt. We all know the seat belt, right? That's
Yes,
why
sir.
we already discussed this point in the earlier classes.
Yes, sir.
So will you tell me what was the situation? How the seat
Uh,
belt?
when if, as soon as if the car is running fast and immediately brakes, the belt pushes you back from falling.
So it somehow help us keep ourselves. Now the third law we will start. We already discussed in the first class, right?
Yes, sir.
So what is third law? The third law is
Every action, there's always an equal or opposite reaction.
you may write it down.
So done.
So see these figures. If we pull the ball, okay, ball will put a force over here. If we hit our head on the wall, ball will hit you back,
Yeah.
right? Are you
Yes.
are you got the concept?
Yes, sir.
When a ball exerts force on the ball exerts equal force on the ball in the opposite direction, right?
Hmm.
The same is for this figure. You may measure this quantity. You buy two the spring balance, right? Go and
Yes,
buy
sir.
it. Okay, go and buy it. To cheaper one, not expensive one, from any store, and do the same procedure. Tie one to the wall and another one. So you will read the reading over there, right?
Yes, sir.
Will you do it? It will give you a measure that how much force you can exert.
Hmm.
You do, then try some elder to do as well and see the how the situation changes, right?
Okay, sir.
This is also the further we have example of push and pull. Okay, when we walk, we push the land back. Okay, and in reaction we move forward. Same happens with this swimmer. She pushes back the water, and water pushes up this side. Same happens with the rocket. Have you seen the rocket?
Yes,
Fuel
sir.
burn, fuel burns and it eject this ball, and this rocket moves this ball, right?
Yes, sir.
So have you any idea of third law now? How it works and what is it,
Yes.
right?
Yes.
So with definition and these idea, this is gun one. Same. When this bullet is being fired, it moves with some force. This force is being at act to this gun, but gun is heavier, so the recoil is very less. Have you tried any time the toy gun?
Yeah, toy gun, yes.
So have you experienced this force?
Yes, sir.
So, okay. So these were, I think, introduction for the Newton's third law and the conservation of angular momentum we will do tomorrow. Okay.
Okay, sir.
So do you have any question regarding today's class?
No, sir.
Are you completely satisfied or you are just
Yes, I understood everything.
Okay, then. See you tomorrow. Okay.
Okay, sir. Thank you, sir.
See you.
Take care.